All right, so this is an example of the first type that we did. If you just are taking the derivative, so differentiate means take the derivative, right? And it is a natural log. So the derivative of a natural log is going to be 1 over whatever this is, right? And then on top, you're going to have the derivative of that. So if you're looking at the form of that, it looks like this, u prime over u. U being the function that is within the natural log. U prime is the derivative of that function. So we're going to say, what is the derivative of 4x squared? Well, that's 8x. So that's my numerator. And then the 4x squared is going to be my denominator, all right? Now, once you do that, you can then reduce it. So I can reduce the 8 and the 4, and I can reduce the x and the x squared, and I'm going to end up with with 2 on top and with an x on bottom. So I can reduce these by 4. I can reduce these by one of those, and I'm going to get 2 over x as my answer. Next type of problems, which start at like number 5 there, are ones where you are going to want to expand before you start taking the derivative. So we're going to use our rules of expansion here before we do anything with derivatives. So we're going to rewrite this to the natural log of this whole group to the 1/3 power. And then to expand it, we're going to take that 1/3 and put it in front. 1/3 times the natural log. And remember, division can be separated by subtraction. So we're going to say the natural log of 2x squared minus the natural log of 2x to the 5th minus 5. All right? And at this point, we can take the derivative. You can distribute that 1/3 if you want to right now. So you could say, okay, go ahead and put that 1/3 through to each of these and say 1/3 natural log of 2x squared minus 1/3 natural log of 2x to the 5th minus 5. And then you can take those derivatives individually. So I'm going to say 1/3 times the derivative of this guy is going to be 4x over my original 2x squared minus 1/3 times the derivative of this is 10x to the 4th over 2x to the 5th minus 5. All right. Reduce this and then simplify, and I'm done. So technically I've taken the derivative, but this is not as simple as it gets. And so I'm going to want to reduce some things that I can reduce, like I can reduce the 2 and the 4. I can reduce the x and the x squared. And then for the other piece, it really can't reduce, all right? So you cannot reduce the 10 and the 2 or the x to the 4th and the x to the 5th because of this minus 5. All right, so he's kind of stuck there. With this 2x squared minus 5. All I'm going to do here is get a common denominator. So this little group here is 2 over 3x minus 10x to the 4th over 2x to the 5th minus 5. All right. And then I'm going to really cross multiply here, like, do the common denominator. So my denominator is going to end up being 3x times 2x to the 5th minus 5. That's my common denominator, right? Both of them already have a 3, so I don't have to worry about that. I need to multiply this 2 by the 2x to the 5th minus 5. And I need to multiply this 10x to the 4th by that x to get that common denominator. So up here, I'm going to distribute that 2. Okay, so I have 4x to the 5th minus 10 minus, this is going to be 10x to the 5th. And then down here, you can distribute if you want to. It doesn't matter either way. You can leave it as 3x times 2x to the 5th minus 5. That's okay. it doesn't matter. It's not going to help you to distribute or help you to keep factored. Either one's fine. I do want to combine my like terms here, right? So 4 and negative 10 give me a negative 6x to the 5th minus 10 over 3x, 2x to the 5th minus 5. The only reason it helps you to leave it factored in the denominator is if by chance this was a 2x out here, let's say this was a 2x and this is 2x to the 5th. If this were a 2x out here, I could actually take a 2 out of everything, right? So leaving it factored in the denominator does help you to see if you could possibly reduce it. In this case, you cannot reduce it, so it's neither here nor there. But leaving the denominator factored will sometimes help you see if you could reduce it. So if 3 went into the 6 and, like, say this was a 9, say this was 6x to the 5th minus 9, and I have a 3x out here, I can see that, oh, I could divide a 3 out of everything. All right, so that's why I typically leave it factored. But either way is fine. That is your answer right there. To integrate, which I don't know why the directions don't change, they should have. But it's starting at 8, you are integrating, okay? So when you see this symbol, you have integration, which means antiderivative. And what you have to look at is you have to say, I have a denominator. So I have this denominator, is it to the first power? And the answer is yes, it is. And so if I have a denominator to the first power, natural log is going to be in there somewhere. All right? So I'm going to look at my denominator and say, first, is my numerator the derivative of my denominator? No, the derivative of my denominator is 6x squared. Okay? But it is an x squared, so I should be able to do u substitution with some type of multiplication or division to get what I need to get. So if I set the denominator as my u, 2x cubed plus 3, the derivative of that is 6x squared dx. I don't want a 6x squared dx. I want a negative 24x squared dx. So I'm just going to multiply both sides by negative 4. So negative 4 du will equal negative 24x squared dx, which is what I want. So I've accounted for everything. The negative 4 times dx gives me my negative 24x squared, right? And I can just put the negative 4 out in front. That's fine. And then my u is to the first power in the denominator. And now I have a really easy natural log. The antiderivative of something in the denominator to the first power is just natural log of that function. And I had a negative 4 that was multiplying by it. And because it is an indefinite integral, I need a plus c. And my last step here is to plug that u in with what I had set u up to be. So it's going to be negative 4 natural log of the 2x cubed plus 3 plus c. And then I am finished. All right, so the difference between this and the other one is strictly that you have boundaries. So you will not have a plus c, you will have an actual answer. All right, that's the only difference. This is actually a really easy one. This is going to be negative 3 times the natural log of x, right? Absolute value of x, right? From negative 4 to negative 1. All right? This wouldn't work if I didn't have absolute value, because if I did natural log of negative 1, you're going to get this beautiful error in your calculator. You can't take natural number e, 2.17, and make it a negative number by taking it to an exponent, right? So it has to be absolute value here with it's just x. And then I'm just going to plug it in. So I'm going to say negative 3 natural log of my top boundary minus negative 3, so we're going to say plus 3 natural log of my lower boundary. And you should, and so if you look in your answer key, it actually has negative 3 natural log of 4 because they just condensed it. I have the natural log added. I'm going to plug this into your calculator and you should get approximately 4.159 when you put that into your calculator. All right, so for this one, there is no natural log, right? And so you're actually going to natural log both sides is what you're going to do to take the derivative here. So I'm going to say, well, the natural log of y and the natural log of that. Remember, whatever you do to one side, you can do to the other. And after I've done that, I'm going to take the derivative. The derivative of this left side is just the derivative of y prime, over my original function, y. Before I take the derivative of this guy, I'm going to expand. Well, how do I expand? Well, that exponent can go in front. So I have 4 times the natural log of 4x to the 4th plus 5. And so now I can take this derivative. I've already taken the derivative of the left-hand side. This is going to be 4 times the derivative of the inside here, which is 16x cubed, over 4x to the 4th plus 5. And that equals y prime over y. Well, what am I solving for? I'm solving for y prime, right? That's what I'm solving for. And so I need to multiply both sides by y to get rid of it and to get y prime by itself. So I'm going to multiply the left side by y, and I'm going to multiply the right side by y. But instead of writing y, I'm going to write what y was originally. Y was 4x to the 4th plus 5 to the 4th. All right. And so when I do that, I can cancel, right? I can cancel this denominator with one of these. That becomes cubed. And then I can just simplify 4 times 16. Well, that's 64x cubed times 4x to the 4th plus 5 cubed. And that is my derivative. Remember, when you have something in the denominator to the first power, you're immediately going to check, does the numerator take care of it? It almost does, all right? Because if I were to do u equals the tangent of 5x, then du would be the secant squared of 5x times the derivative of 5x, which is just 5, right? So I would get 5 secant squared 5x dx, and I actually need 15. So I'm just going to take that guy and multiply by 3. So if I multiply both sides by 3, then I will get that 3 du equals 15 secant squared of 5x dx, and I have exactly what I need. And so I can multiply that by 3 and just take the antiderivative of my 1 over u, which is just natural log, right? So 3 times the natural log of that u plus c. And what was my u? Well, my u was tangent of 5x. So 3 natural log of the tangent of 5x plus c.